Welcome, third graders. Yesterday we were learning how to add fractions, so today we will be adding on to that and subtracting fractions. Our learning target for today is to be able to subtract unlike fractions, and then just like yesterday, you'll show evidence of your learning that by taking a couple of fractions and accurately subtracting them, showing your work. So, situation of subtracting. We have Leo eating 1/2 of a pizza, Miranda eating 3/8 of that same pizza. So the question is who ate more and how much more? When we see those kinds of questions, we know that's leading to subtraction. How much more? Yesterday we learned that with unlike fractions, when we're adding, we first need to change them to fractions with the same denominator. So sometimes we may have like fractions already, sometimes we won't, and so we need to make them like fractions to subtract, just like with adding. So what that would look like back with this problem then, as the diagram is saying, first, find an equivalent fraction to 1/2 that has the same denominator as 3/8. So the original problem down here is 1/2 minus 3/8. And when I see these denominators, I can tell that I can make my 1/2 into a fraction with 8ths as the denominator. So I'd ask myself 2 times what would equal 8, and therefore I would do the same to the numerator, and I'd get 4/8 as my equivalent fraction. Now that I've got like denominators, I would subtract the numerators. 4/8 minus 3/8 equals 1/8. And then the nice visual here shows that if I'm starting with the larger amount, 1/2, which is equivalent to 4/8, and then take out the 3/8, that leaves me with 1/8. So Leo ate 1/8 more of the pizza than Miranda. Another problem, subtract 2/5 from 7/10. Notice that word from. So following directions here, what that means is I'm going to start with 7/10 and then minus 2/5 from that. So looking at these denominators, they're unlike fractions at the moment. To easily make this a subtraction problem that I can do, I would turn this fraction into a fraction with 10ths as a denominator. So 5 times 2 would equal 10, and therefore 2 times 2 equals 4. So my new problem will be 7/10 minus, this should be a 10, sorry. 7/10 minus 4/10 will equal 3/10. So again, nice model showing that we're starting with the 7/10, subtracting or taking out the 4/10, leaving us with 3/10. Another problem, subtract 7/12 from 5/6. So again, notice how it's worded, and we'll write it like this then, starting with 5/6, because we'll want to start with the larger fraction anyway, minus 7/12. Looking at these denominators, I'll want to take this fraction and find an equivalent fraction with 12ths as the denominator. So 6 times what equals 12, and multiply the numerator by the same. So that will give me 10/12. 10/12 minus 7/12 would leave me with 3/12. Now it has another space for another answer here, because when I look at 3/12, is that in simplest form? Both the 3 and the 12 are divisible by 3, So I can reduce that fraction. 3 divided by 3 is 1, and 12 divided by 3 is 4. So 3/12 written in simplest form would be 1/4. Let's take a look at how that would be shown on the model. So this whole bar is divided into 12 equal spaces. So notice not all of them are shaded in because I'm not working with a whole, I'm working with fractions. So we started with 10 of the 12, so this brace up here is showing 10/12. Then subtracting 7 of those 12ths would leave us with 3/12. Now, 1/4. If I think about, well, let's see. Let me change colors here. If we divide this into fourths, 2, 3, 4. A fourth is 3 little squares. So that's again showing you that 3/12 is equivalent to 1/4. You give it a go now. 3/4 minus 1/2 is your problem. Pause and solve, and then come back and check. 3/4 minus 2/4. Did you find an equivalent fraction for 1/2 so that we could have like fractions with fourths? 3/4 minus 2/4 equals 1/4. How'd you do? Another practice problem. 2/3 minus 5/9. Go ahead and pause and solve. Since we've got 3 and 9 as denominators, I'm going to find an equivalent fraction for 2/3. Let's see. 3 times 3 would equal 9, so 2 times 3 would be 6. So my problem now is 6/9 minus 5/9 would equal 4/9. Is that answer in simplest form? Yes, I wouldn't be able to divide both the numerator and denominator by the same number. Whoa, we've got 3 fractions here. 13/14 minus 2/7 minus 3/7. Well, I'd keep following those same steps. I've got 14, 7, and 7. So let's make common denominators. And looks like working with 14ths is probably going to be what we want. So 7 times 2 equals 14, so 2 times 2 would be 4. And likewise, 7 times 2 equals 14, so 3 times 2 would be 6. Okay, now all I need to do is subtract the numerators. 13 minus 4 would be 9. 9 minus 6 would be 3. 3/14. You give this one a go, and then come back and check. We'll use the denominator of 12ths here. So we've got 11/12 and 1/12. So 4 times what equals 12? It would be 3. So 3 times 3 would equal 9. So 11/12 minus 9/12 would be 2/12. Minus 1 more 12th would leave us with 1/12. How did you do? Your practice today, there's lots of options, but they're hopefully becoming very familiar to you. We've got a couple of worksheets you could print off if that's working for you. There's IXL you can choose from. That these are just being added on to our recommendations. So these are some subtractions. One of them's got some models that you can look at, and the other one just has the fractions. There's also a brain pop. So Tim and Moby will share a little bit about subtracting, and you could take that quiz. So well done, third graders. Now you can add and subtract unlike fractions. To show your learning today, remember to go back into Seesaw and complete the problem there, showing your work. We'll be back next week with more fraction work.